thank you everyone for joining today's presentation event. And thank you to our presenters, Matt Brogan and Aaron Silva. I'll hand it over to Joseph for introduction since my sound is not that clear.
All right. Oh man, what happened to my thing here? All right. Well, thank you so much for joining this combo webinar of the Central Valley Branch and the Capital Branch. We have a presentation today from Mark Thomas. They did the Divergent Diamond Interchange DDI in California. We have Matt Brogan. He's a PE, and also Aaron Silva, PE with Mark Thomas. And they're going to talk about the development of the DDI at the State Route 120 and Union Road in the City of Manteca. And a little bit about Matt and Aaron. Matt is a PE division manager and principal engineer at Mark Thomas. Matt has over 24 years of experience in transportation engineering and 20 years solely devoted to planning and design of highway and interchange improvements. Matt leads the Mark Thomas Sacramento office and serves as principal in charge. He also managed a variety of transportation improvement projects from planning all the way to final design. His project experience includes local roadway improvements, highway interchanges, corridor studies, bicycle facilities, civil related transit improvements, streetscape designs, bridge replacements, and downtown infrastructure improvements. Matt has been a project manager for more than 30 Caltrans projects and has a depth understanding of Caltrans standards. Second speaker today is Aaron Silva. He's also a PE at Mark Thomas. He's a senior project manager and associate engineer. Aaron Silva has over 16 years experience in the design and delivery of transportation projects. He is an innovative geometrician with a focus on developing creative solutions to challenging projects. He currently teaches geometric design to Caltrans staff through the UC Berkeley Tech Transfer Program. While working on the SR 120 Union interchange, Aaron served as the leading partner with Caltrans in developing the Design Information Bulletin, the DIB 90 for the Divergent Diamond Interchanges. Aaron's attention to detail and creativity is evident in his project designs. So further ado, I'll let Matt and Aaron take this away.
Great, thanks, Joseph. Everyone hear me okay? Yeah, gotcha. Good. Okay, great. Yeah, thanks, Joseph and the rest of the ASCE branch for giving us this opportunity to talk about our experience on two Divergent Diamond projects, one at State Route 120 Union Road in the City of Manteca, and we'll give an update on our ongoing work at I-580 Patterson Pass. And before I move forward, I do see Alfredo Manhango from the City of Manteca is on as well. So we were strong partners with the City and Caltrans in delivering what is, the first of its kind in California. So excited to be here and talk to you about it and answer any questions. So next slide, Aaron. All right, so for those of you that don't know, but it sounds like most people are familiar with where the City of Manteca is, right in the heart of the Central Valley. The city is very much growing. It's frankly a bedroom community to the Bay Area, and it really experiences a high volume of peak traffic into and out of the Bay Area, depending on the AM and PM peak hours. So our project was right along 120 at Union Road. The State Route 120 was built originally in the 1960s as a 2-lane facility and was widened to a 4-lane facility in the 1980s. There's 3 main interchanges along State Route 120, Union Road there right in the center, bracketed by Airport Way and Main Street. What you might not be able to see from this photo, there's a lot of residential development on the north side of 120. And a significant amount of ongoing and planned residential and commercial development on the south side of 120. State Route 120, as I mentioned, really experiences peak traffic. It's one of the main routes from Stanislaus County into the Livermore area. It's a main connection between State Route 99, I-5, I-205, and I-580. So it really does experience a peak volume of traffic going into the Bay Area in the morning and coming out from the Bay Area in the evening. So that's just the existing site conditions. So next slide, please. Another photo showing the specifics of Union Road. Prior to our project, it was a spread diamond interchange with a 2-lane overcrossing with signalized ramp terminal intersections that were constructed in the mid-90s. Next slide, Aaron. So the city had been working on planned improvements at 120 Union Road since the late 2000s. What you see on the screen there is what had been originally planned was a typical Caltrans L9 partial cloverleaf interchange with a bridge widening and associated ramp improvements. At the time, the city brought that project to about the 65% design level and then started to run into some real challenges with mainly the overall budget for the improvement. This was about a $30 million interchange in the late 90s, probably a $35 to $40 million interchange in current dollars. And the main challenge from a budget perspective is because of the addition of those 2 loop ramps, it would have required the replacement of the entire bridge structure. There were some vertical clearance challenges with the associated loop ramps, which required a new structure, a completely new structure to be built. So at the time, in about 2009, 2010, the city put the project on the shelf. There was obviously downturn in the economy at that time as well. And so the project sat dormant for a period of 4 to 5 years. Next slide, please, Aaron. So as we started talking with the City of Manteca about, the potential for revisiting the interchange improvements at 120 Union Road, there was some forethought by the city to look at alternative and innovative design concepts. And what you see on the screen there is a skeleton version of the Divergent Diamond. And at the time, in about 2013, when we got involved with the city, we knew that the Divergent Diamond technology existed in the United States. There was probably 20 to 25 of them in operation or in plan development somewhere throughout the country. But Caltrans and no one in the state of California had done a Divergent Diamond configuration. So at the time, we did some initial high-level traffic analysis to understand if the Divergent Diamond was an option that would relieve the congestion, not only on State Route 120, but on the local road there along Union Road. We did enough traffic analysis to know that it was a viable option. That high-level analysis was presented to Caltrans to see if they would be open to the concept. And in fact, they were. And so in about 2014, we started detailed development of traffic forecasting, environmental documentation, concept geometrics, and moving the project through a reinitiation of the environmental document phase and into final PSNA. Next slide. So what we were starting with, in particular, the state of California, as I mentioned, there had not been anything specifically developed with Caltrans guidance. There was some level of design standards for diverging diamonds through FHWA that was some best practices from DDIs that had been constructed and operational in other states, along with a very, very draft version of Design Information Bulletin 90. Aaron's going to get into some more detail of what was included within DIB 90. But what that is it's a design standard for features that need to meet Caltrans Highway Design Manual guidance, but frankly on the newer end of transportation technology. So throughout the time, we had started with the FHWA guidance. We worked with Caltrans District 10, Caltrans headquarters staff on the development of DIB 90, and we really started to dig in the details of how this diverging diamond would operate from a traffic perspective, how the geometric constraints would be addressed, and how we would move this project through into the PSNE phase. So Aaron, I think you're up next, if I'm not mistaken.
Yeah, I'll just add that both, it took a collective effort with the city and Caltrans to push the envelope at this stage, seeing that there weren't adopted standards at the time. they're both huge project advocates and were a huge contribution to the success of the project. So just to take a step back about what a diverging diamond is and how traffic operates through it. It's a diamond interchange. You could see this is our geometric drawing that we prepared in the process of getting the project approved. We have a 4-lane overcrossing over Union Road. Existing was a 2-lane, and so this would require bridge widening. And then we have tight diamond on and off ramps. Both off ramps had dual lefts. One off ramp had dual rights to service the traffic demand, but it's a very compact design and efficient design. And the key aspect of a diverging diamond is these crossover intersections. So as you're traveling, in this case, north is pointing to the right. If you're traveling north and south, you approach the ramp intersection, you cross over to the opposite side of the road. This allows for free movements onto and off of the freeway. And then when you get to the other ramp, you cross back over to the original side of the road of Union Road. There's a few ways you could handle the traffic operations. If there's a heavy through movement during a certain peak time, you see in green, you could synchronize the signals to allow that through movement to go through with both green phases, while you have off-ramp traffic queuing up over the overcrossing. Alternatively, if at a different time during the day or during a peak, you have heavy on and off-ramp traffic, you could prioritize those and have the ramp signals flush out traffic on the ramps and through the interchange and onto the local road. One thing also that the Union Road or the Diverging Diamond Interchange configuration does well is increase safety. So not only just from an operational standpoint, but from a safety standpoint, you have lower speeds. This graphic shows the number of conflict points of a typical diamond interchange versus a DDI. It greatly reduces not only the number of conflict points, but the severity of crossings that you would see at a typical diamond interchange. So in basic summary, a DDI is not much unlike any other diamond interchange other than the intersection control. You still have on and off ramps with left and right turning movements. Early on in the development, DDIs, especially over in the Midwest, had very large sweeping turns. This was more in the setting of rural applications where there wasn't a lot of pedestrian and bicycle traffic. But here in California, one of the main focuses is on non-motorized users, so our bicycles and pedestrians. And so now we're looking at more compact design, sharper turns to control speeds at those vulnerable points where those crossings are happening. I wanted to walk through, now that it's open and operational, some of the key challenges associated with getting this project from something that hadn't been done before in California through a Caltrans approval process. So I identified these 4 main topics. First, getting the alternative approved, walking through some of the geometric changes, utilities, which happens on most every project that we deal with, that becomes a challenge, and then stage construction with this, which is specific to the DDI. So Matt alluded to it earlier, because the city had already had an approved alternative with the L9 or the partial cloverleaf interchange. What our team did first was process a supplemental project report and an environmental revalidation. It was a relatively quick process. It was supported by the traffic analysis that was performed by our partner Fair and Peers. What it showed was that both interchanges operate pretty similarly, and that's because of the efficiencies of the tight diamond. But the benefit it did bring was a reduction in project costs. We were able to maintain the existing structure and avoid right-of-way acquisitions. So getting this alternative process was a relatively straightforward exercise. It just followed the Caltrans process. When it came to geometric design, there's one key aspect to the diverging diamond as it applies to DIB 90 is this DDI boundary. So everything outside of this blue box, it follows the highway design manual, from ramp divergence, lane widths, super elevation profiles. all of that is still consistent. But when you are within this boundary, that is where DIB 90 comes into play. And it's because in order to control the size, speed, and operations of these crossover intersections, there's very specific design elements that aren't consistent with the Highway Design Manual. I was going to walk through some relatively quickly, just so you could see what those main differences are. In the Highway Design Manual, typical interchanges are designed to a minimum design speed of 45 miles an hour. With DIB 90 or the DDI, the range is now reduced to a maximum of between 25 and 35 miles an hour. And what that does is it helps control the size of the crossover intersections. And that reduction in speed actually it brings another safety benefit, especially when you're thinking about on-street bicycle facilities or pedestrians crossing the ramps. You have much lower operating speeds. Super elevation with these crossover curves, if standard super elevation was applied, they'd be really large curves or highly super elevated, which means it's the cross slope of the road would get banked. But with DIB 90, you could use an adverse super or a normal crown through the crossovers. And again, it just improves the drivability and the size of these intersections. This one is a slight change. A lot of older interchanges have steep approaches and tight vertical curves over the state facility. And there's a chance of heavy or tall vehicles, heavy loaded vehicles to overturn on steep grades as they intersect with the ramps. Normally that's maxed out at 4%, but with a DDI, it has been increased to 5%. It's because you have these heavier vehicles aren't crossing over the crown where they would have that shift in weight. They would be crossing over, they stay on the opposite side of the road, which helps improve that situation. As far as lane widths, the same HDM standard still applies. So normal lane widths are 12 feet for Caltrans facilities, but through the curves, there's widening for off-tracking. This you see not only in DDI design, but loop off-ramp design. Those inside lanes often are widened for tractor trailer off-tracking, or similar to roundabouts where you have multi-lane roundabouts. The entry or the throat of the roundabout is widened also to control path overlap. And this is what I mean about path overlap. There's the natural progression of people, as they approach an intersection, to head in the direction that their approach angle is. And so it's really critical to provide that striping to help control that movement. This one was pretty interesting. Bike paths in the HDM stage, they shouldn't be placed in the median, but that actually is a pretty standard treatment for DDI design, is putting pedestrians and bicyclists in the center through a class 1 path. So DIB 90 addresses that. And then some of the just really key main points about these crossover intersections is Caltrans requires a crossover angle of between 40 and 45 degrees. And the reason for that is it really helps control the potential for wrong way movements. It encourages the vehicles to cross over at the intersection. There's other states that have adopted more narrow crossover angles all the way down to 25 degrees, but California is stuck with a steeper angle to help prevent those wrong way movements. In the event that there's a constraint and you need to go to a shallower angle, there are ways to get approval, just like a normal like interchange project through the HDM. There's a design decision document to document non-standard features. But you would want to make sure you're meeting some of the performance checks. And one of them is that you want to make sure that those eyebrow islands, the island that's highlighted in green, intercepts the clear line of sight. So a vehicle, it's clear that there's an obstruction and it cannot continue forward on wrong way approaching traffic. Another element is having a nice tangent in between the crossover curves. Similar to the path overlap, you want people lined up through the intersection so they complete the crossover and understand which direction they're heading. Not always unique to California, but especially important in California is our ramp metering. Shown are two graphics. One on the left is how the interchange is operating right now with the local road approach as a yield shown in red. And then in between the ramps, we prioritize the ramp movement. But as installing a traffic signal on the ramp it has the potential to build up vehicle queues. And what may happen is those queues may extend back to the adjacent intersection or the ramp. And that's where you start seeing operations break down. And what we've done to address that is install loop detection near the where the queues would extend, and it's essentially a queue detection. And in the future, if that becomes an issue, what could happen is we signalize, shown on the right, we signalize the local road movement to prevent them from entering on the ramp, still prioritizing the ramp movement between the two ramp intersections. That way we could control the queues and not affect the adjacent traffic signal. From an active transportation standpoint, we have several options of handling bikes and pedestrians. Shown in the yellow line is a typical path through a diverging diamond, where you cross pedestrians into the eyebrow islands and then into the center median and then back out. There's another option of keeping pedestrians on the outside. You typically see this on undercrossings where there might be obstructions like bridge columns that would be occupied in the median, and you would keep the pedestrians on the outside. And then there's what we did at Union Road. We prepared plans for a grade separation or grade separated bike path. So it carries both bicycles and pedestrians, and it's completely grade separated from the on and off ramps in Highway 120. And this was presented to City Council, and it was approved as a design element. And then the city was fortunate enough to work with SJCOG to get additional funding to fund the construction of the additional structures of for the grade separated path. We've done something similar to this in District 3 at Watt Avenue, Highway 50, where you see the path. It's very nicely landscaped. You don't feel like you're going through an interchange, especially with interchanges that experience high volumes. Separating those uses is a huge benefit, and we have options for people that can use stairs to take shortcuts or take the path that it loops up on itself. And then here's a picture of it constructed at Union Road. Highlighted in blue is the path, so you can see users can cross both ramps and the freeway without having to cross a single lane of traffic. Now to our next challenge. It came down to some overhead utilities. So the existing site had wood pole overhead electric lines, and the span was too great to be able to remove all the facilities outside of the Caltrans right-of-way, which required a policy exception through Caltrans. This was one of our bigger hurdles, and it just became challenging because of lack of documentation between the utility owner and Caltrans as far as prior rights and the master agreement between the state and the utility owner. So it did require almost a year straight of constant coordination to getting the utility relocation processed and approved, and this policy exception of keeping utilities within the state right-of-way approved. In the end, it was a relatively expensive, I think it was a $2 million relocation with these large towers that were installed as part of the construction of the project. And then stage construction. So the next couple slides, you can see the project in construction. This is showing the widening of the existing overcrossing. You can see it's much wider than what was out there before. The new ramps were constructed on the eastbound side or the east side of the overcrossing, while the old ramps were in operation. But then the contractor came back to the city and Caltrans and proposed a alternative where they could shut down the westbound ramps. And what that allowed them to do is really accelerate the construction. It saved the city quite a bit of money in construction with this approach, and it was great to have Caltrans being able to approve this change in the fields. One of the benefits is that there's mile spacing between local interchanges on 120, so the detour routes were relatively direct, and it really enabled the city to be able to shut the interchange down for several months to help aid in that construction. Here's the detour plan. And it actually went a step further. And one of the biggest challenges with a diverging diamond is how you start the crossover, how you initiate the crossover, because everything operates as a tight diamond with typical right and left turn movements. And in order to really get the crossover to operate upon opening, you need to have the final striping and the signals operational. And the signals being operational, that means you're putting in foundations where there might be some existing traffic control, running conduit, getting the cabinet set up and testing. And so that does take quite a bit of time. Originally, it was thought to take about a 2-week period, but with the closure of the interchange, the contractor and Caltrans inspection was able to go ahead and implement those improvements without live traffic, and then reopen the interchange in its final configuration. So if you're faced with doing a diverging diamond, I would suggest fully vetting out how stage construction and that changeover will operate early on in the process and getting that approved. Now that it's operational, we've really hadn't heard any feedback, negative feedback from the community and the city. It is operating very efficiently. One thing that did come up that was interesting, and it's actually identified in the update from the NCHRP report on diverging diamonds, is driver expectation. So shown in the red line is from the viewpoint of the white vehicle and the off-ramp. They're typically looking for oncoming traffic on that side of the road. But because we're crossing traffic over at these intersections, the oncoming traffic is there. And so the city did hear back that it's tough to see where the oncoming traffic is, and it comes down just from driver experience and expectation. As drivers navigate the interchange, they'll learn to anticipate where the traffic is coming from. You could see that red line is a very acute angle. It'd be tough to see, but traffic is not approaching from that side. So that is not something that's considered, but you do want to check to make sure that you do have enough sight distance for accommodating traffic where that green line is being shown. And then we get into the rendering. Matt, you want to step back in and talk about some of the materials we prepared for outreach?
Yeah, absolutely. So, as we move through final design, we really wanted to understand, how to communicate this out to the public. We went ahead and did a fully rendered model. That's what you see here on the screen. We wanted to get these images out to the public so that they could understand post-construction, how the operation of the interchange needed to take place. So this reflects our rendered model. And if this video is working, I think if you click that, Aaron, yeah. So this is a video of some pre, during, and post construction. So I'll just let this play. But this is, the framework of our initial model, our 3D model pre-rendering. This is our fully rendered model that shows operation of the interchange. And then this is a drone video of the constructed project. So it's pretty cool to see, kind of from concept to reality, how all of this came together. And this was very useful information as we presented, this configuration and this concept out to the public. So I'm going to spend a couple of minutes talking about some ongoing work for a diverging diamond we're doing at I-580 International Parkway in the city of Tracy. Unlike Union Road, there were some pretty significant right-of-way constraints at International Parkway, Patterson Pass Road. It's in the city of Tracy. There are major commercial and infrastructure logistical type developments in the triangle between I-580 and I-205. So the existing configuration is a tight diamond interchange, 2-lane overcrossing, but it has a significant amount of truck volume associated with those adjacent developments. I believe it's about 26% trucks that operate on this interchange on a daily basis. We started working with the city of Tracy about 4 or 5 years ago. The diverging diamond concept did float to the top. And what we're proposing and finalizing construction documents for is a diverging diamond configuration, a bridge widening, ramp configurations, and modifications to address the traffic issues and safety needs at the interchange. I think the biggest difference between City of Manteca's project and the City of Tracy's project is this diverging diamond configuration from a construction cost perspective was about the same as the other alternatives. But what was the major difference in selecting the diverging diamond was we were able to eliminate right-of-way impacts to an existing gas station that was on the south side of 5580 in the city of Tracy. So the gas station went from essentially a full take of an existing gas station to no take at the existing gas station, which probably saved the project about $6 to $10 million in the overall programming cost. Next slide. So purpose and need specific to City of Tracy had the reduction in traffic congestion, increased safety and operations, and was very much in line with the planned development in the Quarters Ranch specific plan EIR. As I mentioned previously, the DDI provided exceptional performance from a traffic perspective, a smaller overall right-of-way footprint, a significant reduction in that right-of-way acquisition, as I mentioned, and some just project stats for you in Tracy. The delay was decreased by almost 47%. The average speed, mainly because of the reduction in congestion, increased by 13%. From an emissions standpoint, because trucks aren't idling in traffic, we had almost a 30% decrease in consumption and emissions. And typical with any DDI, we had about a 25% anticipated reduction in accidents at the interchange. This just highlights the proposed acquisitions. We do have acquisitions from 5 owners. What you see there in the pink, in the middle of those pink lines on the kind of left side of the screen there, is where that existing gas station was able to be saved. And that was, as I mentioned, a huge priority for the City of Tracy. We filed our resolutions and necessities in February, and we're really close to having our utilities certified and our right-of-way certification in place for the improvements at 580 Patterson Pass. Next slide. One of the big surprises we ended up finding out during the development of our 65% plan sets, there was actually a 20% or 20-inch crimson oil facility right adjacent to the existing ramps. Frankly, didn't discover it until we did some due diligence with potholing. And once we realized that we had this large oil facility in place, we had to scramble a bit and modify our DDI design even more. What we had to do was pull those ramp terminal intersections a little closer to I-580. We were able to work with Caltrans District 10 staff, FHWA staff to approve these slight modifications to the DDI concept design. But we were able to avoid that 20-inch oil line and save the city about $5 million from what would have been a very expensive utility relocation. So again, more innovation upon innovation with the DDI that we went through at the City of Tracy. And this is that access to the gas station that I mentioned. While we were able to avoid any right-of-way acquisitions with the gas station, we did significantly modify their access and their frontage to the ingress and egress of their property. We went through a lot of different concept designs with the property owner, needed Caltrans approval for driveway spacing. We needed to look at fuel truck access, delivery truck access, STAA truck access into and out of that gas station. What ended up resulting in the final design solution was that they had full access from Patterson Pass Road prior to the project design. Caltrans, from a safety and operational perspective, required us to reduce that to a right-in, right-out access. So we had a lot of back and forth with the property owner to demonstrate and show how vehicles would get in, navigate through the existing gas station into the pumps, and then egress back out to Patterson Pass Road through a new access road and local roadway connection to Patterson Pass. Again, a lot of interaction with Caltrans, a lot of interaction with FHWA and the property owner to land on this configuration. Just schedule, we're very close to our RTL, ready to list date, April 21st, coming up in about a month. We are barreling towards our California Transportation Commission funding allocation in June of this year. It's a very important date for us because we have about $25 million of state funding on the line that will go away if we don't meet that June 28th and 29th meeting date. But things seem to be on track for us to get to that RTL in April, advertise the project for construction in September of this year. So that's what we had for the presentation. We're happy to answer any questions about kind of the process, the configuration of the DDI, some of the approvals we went through. So I think we'll open it up to any questions that you may have. I guess I'll just.
So what's the timing? You name it A and M. What does the A and M mean? You had 25 and 35, and then 35 and 45, but they had an A and an M next to them.
Which slide was that on?
So I think what you're referring to is this is a little outdated in the fact that they Caltrans referred to design exceptions or design standards as advisory and mandatory. Now they're bold-faced and underlined. So they're essentially how Caltrans divvies out approval. Some can be handled at a district level, and then some require headquarters approval.
Thank you.
Yep. I see a question in the chat. Was there any performance monitoring of traffic volumes, transit times, et cetera, before and after installation of the DDIs? So as a part of our traffic operations analysis that we did with Caltrans, we did a full traffic forecast design year analysis of a 20-year design horizon. What the model showed us was significant reductions in travel time. I think if I think back to the Tracy 580 project, I think we had a 30% decrease in travel times through the interchange. We have not gone back and done any post analysis at Union Road of the operations, but based on the fact that we have not gotten significant comments, I think either from the city or from the public, all indications are that it is performing as we had anticipated with the opening in the construction year. Obviously when you're doing performance metrics for a design year, 20-year design horizon, you're kind of relying on forecast volumes and the outputs of the model. But all outputs of that model did indicate that there would be a significant benefit in performance. Aaron, do you have any specific numbers that come to mind from Union Road either?
No, I would just say we're just now starting to see traffic volumes get back to pre-pandemic levels too. So I would hazard a guess that the design year it pushes out even further than the 20 years that originally we had anticipated. We got a couple free years from low traffic use. So yeah, I would think it would be interesting to see down the road, but like you mentioned, Matt, that the forecast volumes do accommodate for the general plan build out, and that's what we're assigned to. One thing that's kind of critical is what is a really big cost driver on these projects is how much structure widening you may have to do if you're retrofitting. We're right on that threshold of having a 4-lane or a 6-lane facility over 120, and those additional lanes would have been used to service the on and or tip the on ramps. So that's one of those key things that you would need to consider is if you do have structure widening required because you have heavy on ramp volumes and you need to have those additional lanes. The project cost can actually increase significantly just based on the traffic you're anticipating.
Yeah, and then the last thing I'll add, and this is safety related, but for both projects, we did a predictive crash analysis through the Highway Capacity and Highway Safety Manual. It's a pretty high level tool to predict, existing condition, no project versus future project. That's where that 25% reduction in overall accident rates came from, was the predictive crash analysis. So.
Okay. And then Matt, there's another question. Given the various benefits of DDIs over traditional interchanges, was there any state, federal funding specific to DDIs the project was able to use? I'll speak to Union Road. It was a locally funded project. They did get contributions from SJCOG on some of the construction and the construction of the bike path, which added, I think, a $2 million addition to the project costs. And I would just want to also mention that the DDI is one of the tools in our toolbox to be able to address congestion at interchanges, but it's not a silver bullet. These really do start to break down if there's heavy on and off ramp traffic and heavy through traffic. In the case of Union Road, what we're seeing is heavy volumes heading into the Bay Area in the morning commute, and then heavy return volumes. So you don't see those conflicts. When you start having heavy through volumes and heavy ramp traffic is when the operations start to break down, and maybe another interchange type might be available. You want to talk to the funding that was used on Tracy?
Yeah, well, I'll just speak in general. While there's no specific pot of funding related to diverging diamonds, what we're seeing from the federal funding side of things now is a focus on projects that are multimodal, that have either a net neutral or reduction in VMT, and still provide congestion relief for a 20-year design horizon. And a lot of the typical transportation improvements that you see, like a typical L9 might not check all those boxes. So, I think the DDI, while not a very specific pot of money for them, I do think it makes it, you couple that with the innovation, much more competitive for these federal and state grant programs. Specific to 580 Patterson Pass in the city of Tracy, we do have $25 million, I think, as I mentioned, of state funding, and that's competitive SB1 funding related to the Trade Corridor Enhancement Program. So that's the SB1 portion of projects that enhance transit and goods movement throughout the state. So we were able to secure that $25 million grant, mainly because of our access into and out of all of the development at Course Ranch, which is highly focused on goods movement. There's Wayfair, Amazon type facilities, which leads to the heavy percentage of trucks at 580 Patterson Pass. So we were able to secure that TSEP funding because of the reasons I mentioned, the ability to serve that demand from a transit and goods movement perspective while maintaining efficiency and operations at the interchange. So that was a big win for the city of Tracy to get that funding through the state. Great. Any other questions anybody has?
If anyone has any questions, they can unmute themselves and directly ask the question.
Yeah, on that picture that you just had, where's that gas station you were talking about?
Yeah, so it wasn't on the photo that we just had, but Aaron, can you bring up that slide deck? Yeah, so it wouldn't show on the photo, but if you go back, yeah, so there you go. It's right in that location. So it's immediately adjacent to the ramps. I think their existing driveway is probably 75 feet from the end of the ramp terminal. So definitely something that needed to get cleaned up with the access. But if you can picture, a typical L9 interchange configuration through here, it would have wiped out and gone right through the building of that existing gas station. So it would have been a complete take.
I have a question. Are there any more areas within the state that are targeting to put DDIs?
Great question, Alfredo. I should mention, and so right now we're working, and we just kicked this off with the City of Manteca, but because of the success of the interchange at Union Road and 120, Aaron, you're going to flip back, yeah. So we're actually moving forward with plans to develop DDIs at the two adjacent interchanges. So that would be at Main Street, one more back, I think. Yeah. So Main Street and Airport Way, we're currently working with city staff to develop project study reports for development of diverging diamonds. Those two locations, obviously, you can see they're the same interchange type as Union Road. And what we're working with Alfredo and the City of Manteca on is to kind of build on the success of Union Road, develop PSRs for Main Street and Airport, and then go seek federal funding or state funding for the development of diverging diamonds at those two locations as well. So we're very excited to continue our relationship with City on that one. We're also, in addition to 580 Patterson Pass, we're in concept development and environmental clearance phase for a diverging diamond at I-5 Louise Avenue in the city of Lathrop. That one's a little bit different in the sense that it's an undercrossing local facility of I-5 as opposed to an overcrossing. There's, slight and minor differences, really in particular to pedestrian access and access underneath the structure because it's an undercrossing. But we're working with District 10 staff and the city of Lathrop on that one as well.
Yeah, and Matt, there is one, I think, operational in Southern California, and there's probably 10 to 15 getting through their final approvals. So it is something that the state has embraced and is implementing throughout California.
I see, yeah, question in the chat for construction cost of Union Road. I think it was around 22 million by the end of the day at the engineer's estimate, and that included that 2.5 million for the pedestrian grade separated pedestrian path through there. So if you're looking at, you know, kind of comparing just the DDI with an L9, it was a savings of probably 15 million that the city realized by going with this configuration. The cost at Tracy is a bit more expensive. It's a little bit bigger interchange, a little bit more going on. That's about a $42 million interchange cost for that project.
I don't see any more questions, so I can, yeah, thanks Matt, and thanks Aaron for this presentation. Oh, I have one more question from Sue.
Yeah, so I think it was, well, I know the first one in the United States was in Missouri. The origin of the concept, Aaron, do you know that? I don't know if it came from the United States or outside the United States. I want to say it was
in Europe.
Yeah.
Yeah, it was originally conceived and developed and then brought over. Yeah, the first one is Missouri, and then they started doing it in Missouri and Kansas quite a bit.
All right. Yeah, thank you, Matt, and thank you, Aaron. So I'll stop recording.